I will sort of help to coordinate, to moderate the panel, but I would like to give him the opportunity to introduce quickly the general topic of 5G, 6G, and the role of services that that services will have in that scenario. And then I will show a few questions for the other panelists. Gabriele, you are online, and the floor is yours.
Thank you. Thank you, Ernesto. Thank you, everybody. Sorry for not being there. I will try from remote. And we know that the fifth generation, the 5G wireless network technologies have been thought for supporting many different technologies and vertical applications, from devices to machine. And we, of course, latency, not only increasing bandwidth, but latency and the new features in the network are one of the key topics. But we are just at the beginning of a journey in this evolution, because decentralization, transparency, the way of managing security and risk in the network, privacy, are all topics that as much as we move in the new verticals, as more they come at the vision. We have new technologies like distributed ledger that sometimes supposed to solve this kind of problems. We have new technologies in the network slicing or edge computing that are very keen to this. We have new ideas also about very, very big changes in the way that security is done, for example, with quantum networks. So we have this panel where I would like to introduce Professor Franco Vatalaro. He is connected from University of Rome, that has more than 40 years of experience and a very long curricula in telecommunication. Professor Ben Azvine, that is head of security research and distinguished engineer in BT technology applied research. Okay, yeah. Professor Sami, or Dr. Sami Muaidad, that is professor of electrical and engineering and computer science at the California University, and is also area editor for IEEE Transactional Communication. Thank you, Professor. And Professor Marco Anisetti from Università degli Studi di Milano, that is also quite active in computational intelligence and design of complex systems. So we prepared a few questions for driving the discussion. Maybe I can ask also to put a slide on the presentation to the organization.
Yeah, I had prepared one slide with those questions, so we might. I see it on the other panel. Okay, here it is.
Okay.
So these are some questions, and sorry if I jump in, Gabriele, because being here I have this mediator role. These questions are questions that we sent beforehand to the panelists, but we told them you are not bound to speak about this specifically. You can choose one, for example, or which you wanted to comment, or you can provide additional comments. So I just wanted to show to the audience here, and they are now being shown on the larger screen, the 4 questions that we have sent around to our panelists. I don't know, Gabriele, if you want to comment on the questions, I let you go. I let you do that. You want to do any general comment on the questions, and then you can we can have our panelists take turns in addressing our audience.
Well, no, I would like to ask Professor Vatalaro how is his view in the 5G roadmap and the evolution of 5G future services. We can,
so Franco, you go first.
We can ask him and listen to him.
Okay, Franco, then you go first, please.
Thank you. Can you hear me?
Yes, we can.
Okay. Thank you very much for inviting me. Good afternoon. Yes, I will try to give my point of view on the first question that we see on the screen. Of course, we do not have time to go through all the questions, and I will concentrate on the first one, which, by the way, I consider very important for the development of 5G and for the market positioning of telco operators. Because actually we are in an important point now. The services will certainly increase in the future years, and the point is, do we provide? Are we ready to provide those services properly to the customers so that all the ecosystem will go smoothly through the 5G evolution? This is, I think, is very important for all our ecosystem, and particularly for the telecommunication mobile operators business. I think there is one crucial point that must still be addressed, and I will only go through one of the issues, essentially for time reasons, but also because what I'm going to talk about, I think, is really important. Can I show the first slide? Do I? Okay. Yeah. Thank you very much. So I just put a title on it just to delineate the problem. Now we are entering an interesting and important phase, which is the ultra reliable, low latency communications. This is the future challenge for 5G. And I'm not sure that we are really addressing in the right way this latency challenge. Can we see the second slide, please? Until now, 4G and 5G is we see 5G as an evolution of 5G. You know, we can see 5G as an evolution or as a revolution with respect to 4G. If we look at 5G as an evolution of 4G, the path, the business path is smooth, and I think that things are going properly. This is about the so-called EMBB services. So essentially, the mobile broadband, which is the provision of contents, communications to the customers. And what 4G achieved before 5G is really astonishing, because now we can really have content, also real-time content with very good quality through the internet. The internet is overpassing the classical broadcasting services in all the countries around the world. So we have TV distribution, VOD, SVOD, all the similar services smoothly available on our screens. And the path goes through also real-time provision of these services, especially sport events. In Italy, we had a few difficulties last year in providing football, but this was essentially solved in a couple of months. And now we also have real-time high definition services on the screens. This, I think, we must not forget, because was really a great success of the mobile industry. But now the next step is to provide the low latency services, which opens a lot of possibilities, including what is called the tactile internet services of the future. Now we have a difficult problem to solve. I'm not sure that the industry appreciated very deeply the difficulty we have in front of us. And here you see a table as a function of the round trip time, which is the latency. And when I talk in terms of latency, I intend end-to-end latency. There is confusion around that. Many operators consider latency between some reference points. No, latency must be considered end-to-end. Otherwise, the practical effects could be disappointing for the client. So if we consider end-to-end latency, this is just for one kind of congestion control. I put here on the bottom one of my papers where I discuss all these topics, so I don't go through all the details. But what we see is that if we have an end-to-end latency of 50 milliseconds, which is good for eMBB services, as you see, with packet loss ratio of 0.25%, which is typical in networks, we can provide services for 5-7 megabit per second, which is what is needed. But when we go to the domain of URLLC services, we need the lower latencies. The objective is 1 millisecond latency. And also we need increased throughput. Between 200, 500 could be megabit per second, could be appropriate for some, even not all the services, but this could be a target that we can look at. Now let us go to the next slide where I show where is the problem I see. Now the slide is a little bit heavy, but what I want to show to you is very simple conceptually. We need absolutely the edge computing to achieve such low latencies and such a high throughput values. We cannot avoid to have the edge computing, what the ETSI calls MEC, MEC, and this is the typical 5G protocol structure through the user plane. And in the slide I put 2 UPF, the intermediate, and one anchor UPF. And what we see are two problems we have. One is traditional and one is a new one, which we will have in the next time. The first one is that there is no IP visibility because the communication is tunneled through the GTP encapsulation, and this kind of tunneling cannot allow directly MAC to extract the user IP packets. So there are companies that provide already some special solutions that are able to do this, but this is not standard. This is not a 3GPP standard. And anyway, there is a solution. Operators use this equipment, although 3GPP did not solve the problem of tunneling, which dates back times of the GPRS, so the beginning of the years 2000. And this problem is still there on the table, having tunnels, as you see, the two tunnels here shown in the network. But now, unfortunately, 3GPP and Open RAN is not solving the problem and will not solve the problem unless it changes the roadmap, is putting another problem on the table. The problem that we are trying to have the RAN less expensive. So someone decided since release 14 to have the radio unit, the distributed unit, and the centralized unit possibly separated, to have a radio unit close to the antenna, then possibly a distributed unit at about 10 kilometers, and then the centralized unit at about 100 kilometers. This is a short-sighted view of the industry. At the beginning, it can appear that we can save money in distributing all this piece of equipment on the territory. But what happens is that MAC is missing layers now, because MAC needs visibility of IP packets. So we cannot easily bring MAC to the antenna or to the distributed unit. We know that for low latency services, for example, for autonomous vehicles services, we need to have MAC at about 10 kilometers from the antenna. But in this case, it will be very difficult and it will be very expensive to solve this problem. So let's go to the next and the last slide. I think that to conclude, for low latency, ultra low latency communications, MEC, the edge computing is mandatory, and it must be located at a distance not greater than about 10-15 kilometers to ensure the 1 millisecond latency requirement. This is both needed for stability of control loops of the tactile internet services, and also to ensure the throughput, the high throughput of 100 megabit per second or more, that are required by some application. For example, it is well known that if we want virtual and augmented reality, we need 1 gig throughput. So it will be difficult to have this if we don't have low latency. The two parameters are strictly linked between each other. So we should find solution to have MAC close to the radio unit, or at most to the distributed unit. And in 3GPP work, I don't see any possibility to solve this problem. So this could slow down the development of this very important segment of 5G and even 6G. For 6G, I think we will have solved the problem, but for now this could be a problem. So this is a problem for 3GPP, but I don't see even organization like ORAN, Open RAN, to address this problem, because this is clearly a problem of what I call architecture openness. So it's not enough to have the interfaces open, the hardware and software decoupled, the availability of cloud native applications and so on. We also need to give a look to the architectures that we are developing, and this architecture there must be open for the operators to decide what are the kind of services that they want to deliver, so that they can put the piece of equipment wherever they need to do without any limitations, which at present is a reality, in my opinion. Thank you very much. This closes my presentation.
Thank you. Before Gabriele gets to give the word to the next speaker, I would like to say, so no metaverse anytime soon, if things are like that, right? I mean, this is just a comment because metaverse was mentioned many times.
I'm very worried about that, sincerely, because this is a big business implication. This could be considered a technical detail, but sometimes this kind of details have huge business implications.
Okay, sorry for jumping in.
So I'm saying here in front of all these very important colleagues, so that if some of you participate in 3GPP or in this organization, you can bring at least the problem. I don't have the solution, but at least I think it's important to identify at least the problems. And this, in my opinion, could be a big problem. Thank you very much.
Yes, if I can add, I think it's very important to remember to keep focus that latency is important when it's considered end-to-end. You stressed at the beginning. This is, for example, quite different from 5G networks and fiber networks, where you usually talk about latency at the end of the network, no? The demarcation point at the home of the user, but then there are Wi-Fi or even UTP cable and other devices that are not controlled, like various type of PC, for example. In 5G networks, usually we talk about the endpoint of the network is also the device, the end user device, no? Usually, like smartphones, and in future also Google's and this kind of stuff. So this is something that will help in the direction that we important to think about. Yeah. Can you hear me?
Yeah. So you can give the floor to the next speaker.
I think this is a point that is worth. Yes, I think we can ask. We can keep on with Professor Anisetti. We discussed about also this feature needs security and need a new process and new consideration. What can you? The floor is to Professor Anisetti.
Yes. Yeah. Thank you. I have prepared a few slides, so please move to the second one. I would like to go back for a while for the discussion we had in the previous panel about softwareization in the context of IoT. We are experiencing the same softwareization in the context of 5G networks, as also mentioned by the previous keynote speaker. Currently, this kind of softwareization is more dedicated to providing functionality in order to release connectivities to the user. But this is something that is more related to the classical traditional connectivity services offered by the 5G telco operators. what is missing now, in my point of view, and I know that this is a bit, let's say, futuristic and a bit optimistic also, considering what we already, what Francesco mentioned to us, that we need to have additional services that are capable to handle data in a meaningful way. And this should be offered by the telco operators in order to enable, for instance, additional services based on them. For instance, we may have services capable to handle data representation or even data transformation. And these type of services are very important in the context of, for instance, artificial intelligence pipeline that need to have very data intensive connectivity with data sources in order to generate on one side the model or even predict with the model in execution. This is a little bit, let's say, against the actual role of the telco operator, which are more and perceive themselves more like a system integrator than a service provider. So they are capable to develop a very high quality and very vertical solution in different contexts where 5G could be of high importance usage, but they are not, let's say, perceiving themselves as a service provider. And this is a huge, let's say, change in their business as well. So having additional services in addition to the traditional connectivity related one, it's a different job, so to speak. So please move to the next one. Thanks. And but still, this type of services can play a crucial role in the future because they are kind of enable for additional services that will open new businesses opportunities for tech operators based on the notion of service composition. So this data handling service can be composed with others in order to build a more advanced ones. Specifically, the ones rely on low latency and what discussed so far. So these are the kind of enabler for the other services to come, and especially in a context of composition. But we know that we have a lot of issues to solve, including the tunneling thing mentioned by Francesco in the previous presentation, that is blocking us to be capable to find a way to seamless deploy services and offer them in a composed fashion, maybe, and even to modify their shape in order to keep some specific latency constraint. And in addition to this, given the fact that these data handling services will have to face with a lot of regulation on data protection, then we need to rethink about how to ensure non-functional properties in this context, which is in a way similar to the cloud context, at least at the beginning, where we do not have this notion of transparency in the cloud. So we will face similar problem while moving to the edge, I mean the 5G edge, where we will not have any transparency tool, at least in the very beginning, to help us in understanding non-functional properties like security and privacy. But on the other side, we will have a more protected environment where we have isolation provided by the telco operators, and also slice, and also all the other functionalities provided by the telco operator in order to separate the different data flows that could be important for and could be inherited by the service composed on top of these 5G technologies. So please let me go to the very last one. Then what I can see in this direction, which is again a little bit optimistic and futuristic, I have to say, the handling of data in this context will rely in the idea that the edge is the cornerstone. So we need to have edge devices in order to provide the edge continuity and the edge continuum from edge to cloud. And normally this is achieved by private edge, which is perceived as the farthest border of a system right now. But as soon as you cross the edge, then you normally have to cope with privacy regulation. For instance, you need to comply with GDPR and then transform data, etc. And this is a kind of another blocking factor. So can we believe that 5G edge node can be this, let's say, border, and can extend the border of the normal private edge devices in order to be more, let's say, open to additional composed services? And another thing that I would like to go back to the previous presentation by Francesco is that I believe that we will have a lot of very small MAC nodes attached to the antennas one day. And this will jeopardize, so to speak, the data presence in all of these nodes, and then it makes the data handling problem even worse than before. But on the other side, this will really unleash some advanced services based on low latency and, for instance, and based on very proximity level edge nodes in the 5G network. So thanks.
Thank you very much, Gabriele. Are you still? Okay, I have this role to try to be the proxy of the moderator, but can you hear us? Well, I don't think I think there must be some problems in the connection. Gabriele, can you hear us? If not, it will be me who will move on to the next speaker. We cannot hear you.
Move on, thank you.
Okay, now we can hear you. So.
Yes, but I think my connection is not so good, so I don't know why. But
all these telco operators, we don't have good connections. This is so. In that case, I would take the personal pleasure to introduce the next speaker, which is Professor Ben Azvine, which is a long-time friend of mine, or not just a colleague and so I really particularly happy to have him on this panel, and I think that look forward to his contribution. So. Ben, the floor is yours.
Thank you very much. Can you hear me?
Yeah, we can hear you well.
Fantastic. I think I'm the only one without an Italian accent, so I apologize for that, this panel. So I would like to make some comments. I work for British Telecom. We own the largest mobile operator in the UK, EE. And we have an aggressive plan in rolling out 5G services. My comments apply to 5G, but also apply to future networks in general. And I'd like to make, obviously, I agree with the previous speakers. Many of the points that I was going to mention have been covered. I would like to just make 4 very brief points before moving into what we're doing in my area in BT around the future of cybersecurity. And so the points are, from an operator's perspective, we really need to think differently about 5G and future networks from the point that the trust models that we have today are very much based on fixed locations of elements, actors, and interfaces. And that's going to change significantly because of the use of virtualization, as the previous speaker said. I think the softwareization of the network will have a significant impact on our ability to guarantee the security of end-to-end networks. And we're going to have to rely more on software developer security. This is a particularly difficult challenge. As we know, software security is, as the speaker in the previous session mentioned, there are significant challenges in terms of software security. And now all of that all of those challenges are going to be brought into the network space with the exploitation of technologies like network function virtualization and software-defined networking. We're going to see a tussle between user privacy requirements, confidentiality requirements from an application developer's perspective, and network operators need to protect our infrastructure. The use of end-to-end encryption is going to seriously affect what we can do with analytics on our network, and analytics that's absolutely necessary to look at early indicators of compromise, for example, and give us a chance to stop cyber attacks. So that's going to be important. And I think longer term, quantum computing and homomorphic encryption will play a significant role. And the challenge there is that, both of those areas are still in development, and no one really knows when they'll be available. And so the question is, when do we get ready for it, and how do we build our current networks? So I'm going to move on to my slides now, if I can switch to that. And thank you for the generous introduction. What we see on our network is an increased number of attacks, and this will increase with adoption, more and more adoption of 5G services. So we currently deal with around 6,500 cyber attacks on our network a day. And this is because of two factors. One is that we're seeing a lot more organization on the side of the bad guys, on the dark side, and the second reason is technology. I mean, the adoption of new technology, some of which have been mentioned before, IoT technology, AI technology, 5G itself, they combine with the more sophisticated organization on the side of the bad guys, increases the number of attacks. And of course, we're seeing new tactics as well, supply chain attacks, which was also mentioned in the previous session, are on the rise. We know that ransomware is becoming the most significant threat on the internet, and these things will continue with 5G. What drives our research and innovation is very much what our customers are telling us in terms of what's missing in their security, and these are three specific examples of what needs to be done. And I forget, the reason I share this is because I think we have a very capable community of thinkers, deep thinkers in security, and some also from industry. And I think this is what is the current picture of what is missing in security, even with all the advances that we've seen in terms of standards and new initiatives. We still see that 53% of malicious attacks are being missed by existing tools. There's far too long in terms of detecting and remediating attacks. 7 months was the average time taken to identify a breach in 2019. Now that has come down a little bit, but not enough. Of course, there's very little, for companies who want to invest in security, there's very little visibility in terms of the benefit of the security that they implement, and therefore many companies are not investing in the technologies that they need to protect themselves against the threats in the sort of near future 5G world. Now we have the best ringside view of the internet in terms of our ability to look across our global network. We have 16 security operation centers around the world, and these are the locations from Sydney in Australia all the way to El Segundo in California. And obviously we are in the UK. in Ipswich. Sometimes we call it the center of universe, and and that's where our headquarters are. But the ability for us to collect information is unparalleled, and what needs to be done is that information needs to be turned into actionable intelligence and information. So a lot of our research that I'm going to talk about is about, how do we utilize this significant volume of data and create early warning systems, but also guidance around what needs to be done around the attacks on our network, 5G network and LTE and 4G as well. I mentioned that the other challenge is technology, and a big part of what my team does is around looking at the impact of new technology. I've also already mentioned quantum computing and AI, but of course, Internet of Things has been covered by other speakers, and I also touch on zero trust a little bit in my presentation if I have time. So in terms of quantum computing, I'm sure all of you are aware of the threat of quantum computers to existing network encryption. And the danger is that the current network traffic is being recorded. And when a quantum computer capable of doing a brute force attack on a encryption algorithms is available, I'm sure our adversaries won't tell us what they're doing with that data, but it's obvious that most of the current encrypted traffic will be vulnerable. And so the race is on right now in terms of building quantum safe networks. And we are at the forefront of that race. I noticed that one of the questions was, how do we see the combination of hardware-based security and crypto? We're very much at the center of that race in terms of providing agile crypto technologies on our network. And our view is very much, we need both. We need hardware-based security, things like quantum key distribution, technologies on our optical fiber networks, which we're currently working on. But at the same time, we also need to keep a very close eye on the advances in post-quantum crypto. We've just seen the results of NIST assessment of PQC algorithms. And we're currently building test beds in our labs to combine what we have done with quantum key distribution, which is on the next slide. We've been working in this area for quite a while, but actually be able to combine quantum post-quantum algorithms and, where necessary, introduce hardware-based security by putting elements in our network for quantum key distribution, so that we can do the key distribution using provably secure physical layer technology, and use the post-quantum cryptography for all the other functions that we need on our network. AI is a big focus of our work, and we're not just using AI within our security, which is what I call cognitive cyber defense, but we're actually looking at 4 quadrants around intersection of AI and future network security. Weaponization of AI clearly is a worry, and we already see intelligent malware, intelligent algorithms built into malware to detect what kind of defenses we have and evade them. We're already seeing a lot of technology around fake identities, deep fakes, for example. And so we are working on how do we ensure that we can use technologies such as digital signatures around identifying fake content or fake identities and warning people or customers against that. Vulnerabilities of AI systems is a key topic for us, and many of you in the audience may know this, but many machine learning algorithms are susceptible to attacks, adversarial attacks, poisoning attacks, and big part of our research is how do we avoid using algorithms in our detection systems that are susceptible to those kind of attacks. And of course, analytics and privacy is clearly very important, and our focus there is around protection of the AI algorithms, machine learning algorithms that you use, because obviously if they are compromised, the data that they were used to be trained can be reverse engineered, and so we actually have a data breach on our hands. What I want to at this point show you is a number of demos, very quickly, demos of some of the technologies that we've actually built in our labs. And around the point about visibility, we're working with our security analysts in terms of what's missing and what they need. If you're not careful, if you just blindly introduce new technology into a security domain, what tends to happen is people switch them off. And what we've been doing is we've been working on how can we actually make AI systems for detecting and monitoring future networks build around humans. So for that, we've built very advanced graph analytics tools. This is one called Nexus, which essentially takes a portion of data on our network, and then it tries to create graphs of how that data relates to each other. This particular application is around finding suspicious domains on the internet to block, which are being missed by current tools and technologies. And what the analyst is doing, what you see is the analyst actually interacting with this, is that we try to use the AI algorithms to reduce the volume of data and then create some usable graphs of what's going on. And then the analyst is able to interact with that graph. And through the combination of the analyst's knowledge and interaction with the power that we built into the algorithms, the analyst is able to come up with a much more accurate list of domains that are suspicious and malicious than using AI algorithms to do this automatically. We're using epidemiological modeling techniques around building models of networks and using the same models that governments use to assess the impact of COVID on populations to actually simulate the impact of an unknown future highly infectious malware on the network. So what you can see here is a model that is purely learned from data, from communication data on different networks. And then we're seeing the infection of a particular node, and we can start looking at how the entire network is affected if nothing was done, or assess the impact of various remediation strategies around removing the infection, or isolating the infection, or changing the parameters of the network around encryption and authentication, and see how that propagates the same way as we look at how many people get infected in a town and how many people die from that infection. We can do exactly the same kind of analysis using the same principles in this simulation environment. And this is a technology that we use in our project called Inflame, which comes from inflammation, which is a self-healing network security, whereby the system, if I can start the demo here, the system uses the model that we learned through the epidemiological modeling, and then uses reinforcement learning to try hundreds of thousands of different actions using reinforcement learning, and come up with the best 3 actions, which are then offered to a human analyst to take the final decision. We very much focus on this element of incorporating humans and AI together to make decisions, because we believe and we our experience shows that actually they produce more accurate results and faster results than providing lots of automated actions, which are then rejected by humans at the end of it. So this is the latest one that we've done. We're also looking at future threats, particularly around ransomware, and how we could analyze, for example, ransomware transactions on the internet. The same system I showed you, Nexus, is used to reduce the volume of ransomware payments and identify those wallets that are receiving those payments, those ransom payments, and then we're working with law enforcement around sharing this information and trying to shut down the operations around who's behind the ransomware. Again, IoT has been mentioned. I am sure we're developing systems around how we could understand the propagation of malware in a smart environment. In this case, the smart city. This is the collaborative project we did called ResiCav, which was to do with predicting the impact of malware in a smart city with lots of self-driving cars. Now, the same technology is applicable to any kind of in smart vehicle. So it could be drones, it could be buses, it could be trains, and so on. And what's behind this is we've got a lot of open source information coming into this tool that looks at drivers talking about, for example, their cars have been compromised, and we use the same technology to actually look at what we see on open source intelligence sources like Twitter and Facebook and so on, around fake news. For example, fake news around 5G causes COVID, and this is a project that we did around getting that information, analyzing it using our technology, Nexus technology here, and sending information relevant to a physical damage on our network, for example, to the police within a matter of 3 minutes. We can actually find that information on social media, and if you see a post which you see on the right-hand side of one of our masts is on fire, within 3 minutes of it being on fire, and it's in the middle of nowhere where bystanders wouldn't naturally come across that, clearly there's something to investigate there. There's a lot of research around future technologies around open source intelligence and what they tell us. This is a project called Artemis, which uses builds essentially knowledge graphs from open source data. Each of these elements that you see could be a document, 30, 40 pages. It basically does natural language processing and text analytics. And what you see is the analyst finding an interesting node and then looking at the document that created that node for more information. What it does, it reduces the time it takes for analysts to actually absorb intelligence, both classified or open source intelligence. I talked about zero trust. We're going to have to build zero trust networks using 5G, and one of the areas we're working on is how can we replace the existing authentication technology, and one of the projects is around continuous authentication. So this is about creating continuous biometric authentication, which removes the need for user and passwords, or in fact one-shot authentication. And we're currently trialing these technologies in our security operation centers for privileged access accounts, for example, and it's proving to be very, very effective. The final, I noticed Ernesto mentioned metaverse. The final presentation I have is around the work we're doing with virtual reality. Now, this is not metaverse. This is virtual reality used to reduce the time it takes to investigate cyber attacks. And this is technology called Virtual Security Operations Center. The idea of this is that we create a replica of our actual security operations center in the virtual world. We call it VSOC, and obviously there are things you could do in a virtual world that you couldn't do in a physical world. But what you see on here is a replica of our tools that I showed you earlier, network management tools. And the idea here is that you could create this immersive environment for cybersecurity investigations within half an hour. So you actually build one of these environments within half an hour. You then invite anyone from our 16 security operations centers around the world to join using an Oculus Rift, and then they do the investigations around a particular cyber attack. And we find that they find this very useful because it can be customized. It can, you can actually change the layout of this. And we see more and more use of these technologies around increased visibility and increased interaction with the data that we get from our network for particularly difficult investigations. And our aim is to reduce that, 7 months time it takes to investigate, reduce it to a matter of hours with these kind of technologies by accessing the right people in wherever the location is, and bringing them in and combine that with these immersive technologies. That's all I want to say. Thank you very much. I'll hand back to the chair.
Thank you, Ben. Gabriele, are you online? Can we? Okay, then you can resume your. I think there might have been a problem with the connection again. So I don't think, we had an additional panelist, but I don't know whether he's connected or not. No. So in this case, I think that we can open the ground. All the panelists showed us this 5G thing from a different angle. I think there were different angles, and anyway, the common thing is that we are in front of more like building a medieval cathedral than by turning on something, So it will be really a challenge for all our energies and all our research capabilities. So I would like now to open the floor for questions or comments. Okay, so the previous keynote speaker, Professor Elisa Bertino, she has a question. I hope you will be able to hear her from...
Actually, yeah, I have a lot of questions, but let me start with a very technical, basic question. So millimeter wave technology was supposed to be part of 5G. So I would like to ask to the first panelist whether this type of technology has been actually deployed or not.
If I may add one thing, Franco, you may remember that we met, especially when this promise was made shortly afterwards. And you explained to me this stuff. So now I let the...
Yes. Millimeter waves is a technology that is being developed within 5G. The frequencies are very interesting, of course, because being very high, they bring together very large bandwidths. But the channel, of course, has problems to be used because of shadowing problems and multipath problems. Now, the key technology here is MIMO. The several implementations of MIMO. And now, as far as I know, the most advanced MIMO chips that are available are 4x4 MIMOs, and these are already implemented and working. But to get all what we want out of the technology, we need the so-called massive MIMO, or at least a MIMO 16 by 16, which is still a challenge for the technology developers. So to boil down to the real problem, is this technology now in line with the predictions in terms of implementations? Actually, no, it is going a little bit slower than expected, because the technological problems have been found to be more difficult than they were considered. But certainly this is a very important technology. When we will have it available, this will open possibilities for new services. So I think it is a very important technology. It's going a little bit too slow at this time, but we will get it for sure.
Okay, thanks. Are there other questions from the audience? If not, I can ask.
You can ask the second one. Go ahead.
Yeah. No. Okay. So I liked a lot. Again, this is for the first speaker, Professor Vatalaro. The discussion about the Open Run, this problem of disaggregating, moving components. But at the end of the day, why cannot one have a flexible environment? If you need, once the components are in software, nothing prevents you from putting them all together near the antenna. If you have a certain application requirements. So I'm not sure why one should have only one architectural solution. That's the flexibility that we want to have, right? Yeah.
Yes, you are right. The point is that telecommunications are a very standardized field. So it is true that in principle we can do whatever we want, but as a matter of fact, you need standardization because you want volumes of production. So it's not possible that any operators do exactly what they want, because there is a standardization procedure that is long. Now, the good point is that with the new technologies, essentially virtualization and the coupling between hardware and software allows much more than in the past. But in any case, we as a habit that the telecommunication industry has, we always go through the standards. And if a solution is not standardized properly, this can slow down the development of certain applications. This is the point.
Yeah, but that is interesting. We can discuss another time because I have other questions, but I don't know if
let's see if there is any other question, or maybe Gabriele wants. Or maybe Gabriele wants to ask questions to the panelists as the real remote moderator. So.
Thank you, Ernesto. Well, I think one question I think would be interesting is we have a lot of expectation on 5G for the extra features that are not in 4G, like virtualization, separation, but also the topics like real-time localization, near real-time protocol transport for industry application, for example. It's more a question of having put too many eggs in the basket, or not everything is being already used. It's that there is too complexity for the environment, for the verticals to ingest all this stuff, or it's more a question of what the history says. We start with the consumers and then business customer will follow. It's interesting your point on this. What do you think? Is the technology, it has been too much a technology push and we need that the industry will digest all this new stuff, or is something that the operators are waiting for the first customer and then they will?
Yeah, that's true. Yeah, but in the future, really, all this wireless technology will connect really not just people with the phone. Actually, they will. People are talking about bio, nano, IoT. Even I saw this very fascinating idea that you could even connect the chips instead of using wires. You could use wireless technology. I don't know whether there is the whole question of industry. They have, especially today with machine learning, they can dynamically change certain parameters in the production. And they need short times, like in milliseconds. So you need to analyze the data, do machine learning, readjust the parameters of equipment before. That's where it's critical, having a very reliable, ultra low, very quick technology is going to be critical. Okay, but that's in the future.
I think the question, Gabriele, question was, is the industry really, do they see the use cases? How many private network have been actually sold to enterprise customers in the different countries? I say this because in the UAE, I'm part of a maturity model for the 5G. And if you ask the operators how many of these top-level technologies that they are actually not only available in the technology stack which is deployed, but also asked for, requested by the customers. The answer is a little bit, so sorry if I add my own remark, but I think that maybe some of the panelists wanted to say something on this. Is there too much complexity in this technology, and are the use cases from the industry lagging behind?
Well, Ernesto, if I may, I'm involved in a number of projects from the TM Forum, and they are exactly trying to find verticals in order to be capable to exploit all the functionalities provided by 5G. And we are still struggling with the difficulties in finding verticals that can be not so vertical to be custom. So something that could be even offered as a service or something on the kind. So this is exactly what they are trying to do. And they are based on a set of APIs offered by the TM Forum, which is a kind of standard. It's not really a standard, but could be considered similar to a standard. And they want to have these verticals on that APIs in order to see if they can develop verticals of interest for the telco industries.
Now, if I can add a comment, my impression, I mean, looking at the American operators, the mobile network operators, they're very reluctant. I mean, their goal is to make money as much as they. No, but I'm not joking. We saw a very simple example where we were analyzing the 4G protocol. We realized that certain broadcast messages sent by cell tower not digitally signed. You talk to the operator, they say, oh, appending a certificate will take or a signature too many bytes. Okay, and that's it.
I think you are calling in Ben to give his point of view. I mean, also this complexity of technology. Is it sort of in a sense jeopardizing the security?
Indeed, I want to add a comment. Exactly. So when we'll have to use a post-quantum crypto, the signatures will be very long. So would the network operator be happy with these very long signatures?
There was a specific comment. I don't know if the panelists could hear that, and one might be Ben. You want to comment? We cannot hear you. Anna.
Oh, sorry. I have to say, this is not my area of expertise. We have a whole networks team whose job is to look at the verticals around use of 5G, and I know that they're heavily involved in two areas. One is the IoT area and one is the health area. And those are the two big use cases that they're working on. But I kind of, my observation, and somebody who's not in the middle of this discussion, is that I think it's a bit of both. I agree with the other panelists who said that, we're continually looking for use cases that would strengthen our business cases. I think that is absolutely true. So I think going back to the point that the chairman made, I think it's a bit of both. I think it's some technology push and some market pull, but the market pull is in very specific areas. And for us, it's around the IoT and health. I hope that's clear.
Yeah, thank you very much. But there was a specific comment by Elisa that I would like to sort of underline, which is, but some of those use cases will require or will pose some security requirements. And those security, for example, we were discussing the signature checks. In a sense, the security functionalities will need to be there. And so will the operators be there to support this need for security functionalities, even long signatures, as Elisa just said. Sorry, I'm repeating because...
Yeah, definitely. I mean, I think in both of those areas, customers they will not adopt the technology unless it's secure. And some of the security offerings of the 5G are essential. But I think, my job partly is to see what's not there and to look at what we can develop over the top of that. But yeah, I absolutely think that there are distinct advantages for security in 5G to 4G, but I don't think it goes far enough in some cases to protect the privacy of the users.
Yeah, no, that's true. We found a significant bug, a privacy bug, related to the paging occasion of cellular phones, because we noticed that even though when you connect, your phone gets a GUI, which is a temporary identifier for privacy, but the paging occasion is based on the actual IMCI. It's not based on the GUI. And we noticed somebody did a lot of data collection on operators, and these people found 4 years ago the operators didn't change the GUI very frequently. So GUI, you cannot keep the GUI for a week, okay? It has to be changed quite often, and they were not doing. Okay, so, but those are examples of things operators do. But I have a question for you, Ben, if I can ask. So you emphasize the ransomware quite a lot, but isn't that the duty of the organization to protect against ransomware? Why should the network operators be worried about ransomware on the customers? I mean, don't you have a division of responsibility?
Well, can you hear me?
Yeah, we can.
Well, we are an organization and we are target of ransomware as well. And we also are a supplier of managed security services. So many companies come to us to buy the service from us. So our primary focus is obviously protecting ourselves against ransomware. But in those cases where we have advanced technology that could protect our customers who decide to outsource their security to us, and there are many multinational companies who do that, then that's what I'm talking about here, right? So we're, I mean, in addition, you obviously want to protect your customers, the consumers, the individuals from ransomware. So we remove around 2 million threats from our network every year without actually involving the end users. So where we can stop ransomware attacks, we do that. And we do that, obviously, as part of our duty to provide a secure network. but we don't do that without the, for the multinationals without them asking us. It's more around the managed security service that we provide.
Okay, I see, it's clear. But that is that typical of a lot, because I don't see a lot of mobile network operators doing security services. I mean, NTT does that, for example.
Maybe Gabriele can answer that one.
Yeah.
Anyway, there are conflicting requirements about these topics, because we should also take into account that there are principles of network neutrality which prevent the operator to go too deep inside the provision of services. So it's really a very tough matter, this one. In principle, I agree that it should be provided some kind of security service at network layer, but again, there are regulations about that. There is a net neutrality, and the operator cannot do all. But in any case, I know that in many circumstances, the operators do have probes in the net, and they can evaluate if there are some attacks, and they can provide solutions. But we should not consider the operator as someone who can do everything in the network, because this is the law of internet.
Yeah. Everything we do is based on not the data, but it's more based on the metadata that we do. So all of the technology we use is the data that's available to operators. Clearly, we can't do everything. You're right. And I think there's some responsibility on the end customers and all application providers as well. Yeah.
Yes.
So if I may ask a question then. Sorry, I shouldn't even be on this panel, but I can't resist because I'm too interested in this topic. So this is a question that was implicit in what Marco Anisetti has presented. So what will be the role then of the operator? I mean, we are all hearing about pushing services on the continuum. So having services which are value-added services, otherwise they wouldn't be there, and they would be there on the network. So if it's not the operator who will do that, at least the operator needs to give to third parties the capability of doing that. And at the moment, it's not easy we are talking, for example, mobile, vehicles, all that type of services that, we read a lot of papers about. So who is going to develop those services, and who is going to deploy them on the operator network? Because they cannot be kept in the cloud, right? Everybody says that they cannot. So what is the role? There will be third parties, or will be the operators that will do that? For example, support for the new vehicles and semi-automatic or automatic driving.
If I may, yeah. In the context of the TM forum, they are thinking of having marketplace. So means that they will open to third parties to develop and deploy their services in order to support this type of scenario. So I know that they are thinking of using this, but it's still in a very piloting stage. So.
Yeah, I mean, I think for us, we very much see that as a place for us to develop new capabilities. So, I mean, certainly in terms of our research program, there are multiple initiatives around providing security for IoT services, and we don't see ourselves excluded. I mean, obviously, there are some regulations and laws that we can't bypass. But we certainly see that as a massive growth area for us, Ernesto. So but we are slightly different to some other mobile operators. We own a mobile network and a fixed network. And so we have that end-to-end kind of visibility. And security is a massive part of our business anyway. So we don't see it as this is not our job. Now, if regulations need to change, clearly that we'll work towards that. But we see that as a massive growth area for us to provide future services.
Claudio?
Yeah, following up on your question, Ernesto, how much the fundamentals of service design and lifecycle management must change to fit 5G and 6G network functionality and benefit from them? So we talked about the different roles the provider will have, how much and where this new role will impact on the design and the definition of these new services.
Who wants to answer?
I think we are also running out of time, so it would be the last answer probably.
Okay, yeah, but
just there.
There's no one who wants to volunteer to answer. I mean, we are seeing all these tools for orchestrations and stuff like that will have to take place on the network. But of course, the life cycle is not the same as the traditional orchestrations in the cloud, right? So,
yeah, if I may, one of the problem with this is that they at the telco side, they are basically using the same technologies that we are used to use in the service, normal service development, but they are not opening these technologies to the rest of the world, so to speak, in a standardized way, to being back on the standardization thing. So from the life cycle perspective, this could be a blocking factor right now in order to unleash the full potential of, let's say, hybrid composition of services based on some services coming from third parties and others coming from directly from the telco operators. So this is a...
Thank you very much. Okay, so in fact, we are running out of time. I don't know, if you had the final word.
No, I just wanted to say, if I were a telco operator, I would be very scared of putting third-party services on my network. Unless you really say, I virtualize and those are isolated. Because if you look at the status of mobile applications, they have so many bugs. Think about a network having to run it.
Yeah, but suppose we are talking of a private subnetwork of 5G specifically designed for healthcare application. So this, in my opinion, is something, an attractive proposition.
Isolation will be critical. Good, strong isolation. Yeah, then you can do.
Okay, so I let now, sorry, Gabriele, I sort of hijacked a little bit sometimes the role of the moderator, but since you were remote, I try to help. So, but I let you conclude anyway. I think it's your privilege to draw the conclusion. This was a very interesting panel, and so it's up to you to draw the conclusions.
Well, thank you, Ernesto, also for the help from there, and thank you to all the panelists and to the people for the questions. I think we touched a number of topics that are quite important: the architecture, the latency, the end-to-end, the security, what the slicing and separation of concern can give to security, the new technologies that are coming from IEEE and quantum. So thank you, everybody, and have a good continuation.
Okay.
Thank you.
I hope to see you in presence next time.
Yes,
thank you. Thank you very much. And I would like to thank the audience here for being here for the last panel of the day. Thanks, everybody.